Okay, ladies and gentlemen, we're going to talk about quadratic equations. Now, quadratic equation is, of course, ax squared plus bx plus c equals y. So you have two x's, one of which is squared, one of which is not. Your coefficients, these guys right here, a, b, and c, those coefficients are the most important things on graphing quadratics. If a is positive, then it's going to open up. If A is negative, it opens down. Now, that's going to be a key thing when we start going to put all this stuff together. Now, the next thing we have to say is, well, in any parabola, the most important point is actually its vertex. It's either the minimum if it opens up or the maximum if it opens down. So what would be nice is if we could find a way to figure out where is that vertex. Additionally, whereas these pictures are drawn just to touch the x-axis in one spot, many parabolas cross the x-axis, and you have places like this. So it would be nice to find a way to do those as well. That's going to be some number, comma, 0. And over here it's some negative number in this case, comma, 0. That's why these are called the zeros of the equation, or called the solutions of the equation. So that's why we're going to be finding zeros and solutions. The nice thing is we can do all of this work with exactly one formula. Opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Now, we've already talked about this. This, of course, whereas this is the quadratic equation, this is the quadratic formula. Now, the equation, because this has an equal sign, formula because it's what we're going to put the a, b, and c into. Now, as with everything, the first thing we have to determine is, well, what's A, what's B, what's C? Well, let's find an example here. So example number 1, let's go with 2x squared plus 3x plus 1 equals y. Now, I can graph that by going to the calculator, making sure that I'm in function mode. Tell you what, let me make it easier for you to see by using a different one. 1 second. Okay, back at you. In this case, we go to y equals and clear out whatever's in there. And we're going to plug in 2x squared plus 3x plus 1. And we're going to hit graph on that. Now, see, it's over here. Sometimes we have to zoom. Let's zoom standard. That's going to put us back in the usual position. Okay, we got our graph. Now, I want to figure out, let's go a little closer, see what else is going on. And I'm going to zoom in right where I think the vertex about should be. Okay, so we can zoom in, we can see that it is indeed going down through the x-axis and coming back up. So we're going to have two solutions, and we're going to have a vertex, and that vertex has been moved off center. So let's grab this calculator, get him out of the way, and go do a little work. Now, I told you this equation will give us everything we need. The first thing this will do is it obviously will find the zeros or the solutions. So let's go ahead and find the zeros or solutions now. A equals 2, B equals 3, C equals 1. So we say opposite of B plus or minus the square root of, all right, let's put it in here. How about 3 in for that? 3 squared minus 4 times 2 times 1. So we have that in there. Now, all over 2 times 2. So we say negative 3 plus or minus square root of 9 minus 8 all over 4. Now, 9 minus 8, of course, is 1, so we have negative 3 plus or minus the square root of 1 all over 4. Square root of 1 is 1. So I have two different options here. I have negative 3 plus 1 over 4 and negative 3 minus 1 over 4. With that, I come up with negative 2 over 4 and negative 4 over 4. So my places I cross are going to be 0, negative 1/2, comma 0, and negative 1, comma 0. Those are my zeros of the equation. Now, I also told you this formula will give me the other key component. The vertex of every quadratic, the x part is going to be opposite of b over 2a. That's going to be the x part of our vertex. Now, the nice thing is that should look familiar. It's right here. This component right there is the x part of our vertex. So in our case, opposite of b over 2a, which in this case is negative 3/4. So I can already tell negative 3/4, comma something is our vertex. Well, if I know the x part and I know an equation, all I have to do is combine the two. So 2 something squared plus 3 something plus 1 equals y. In this case, I plug in negative 3/4, negative 3/4. Okay, let's do a little math. Okay, by doing a little arithmetic, I can plug this in for every x, and once I've done that, I can simplify the fractions until I get negative 2 over 16, or negative 1/8 equals y. So I take that, put it right there, and my vertex is now negative 3/4, comma negative 1/8. My zeros are negative 1/2, comma 0, and negative 1, comma 0, and I'm ready to graph. So, if this is my graph with a vertex of negative 3/4, comma negative 1/8, and two zeros of negative 1/2, comma 0, and negative 1, comma 0, I'm really going to be focusing on this portion of the graph. So there's negative 1, there's positive 1, there's positive 1, there's negative 1. I'm ready to put all these points on there. Now, this would be negative 1/2. This would be negative 1, so I have my two zeros. I go back negative 3/4. So I go back negative 3/4 and down 1/8. Well, there's a half, there's a quarter, there's 1/8. Just like that. If I connect those three dots, I have my parabola with my vertex here, my two zeros, and this line here, which goes right down the middle of a parabola. That is called the axis of symmetry. And it will always be whatever the portion of the vertex is that goes right down the middle. So in our case, it's going to be x equals negative 3/4. If for any reason you had a graph and a parabola that looked like this, the axis of symmetry would go this way and would be the y component of the vertex. So that is a quadratic graph start to finish. Now let's do another one, see if we can do it just a little more quickly. Okay, here we go. A equals -1, B equals -8, C equals 5. So I try to find all my key components. Let's see if we can solve for 0. So we have opposite of B plus or minus the square root of B squared minus 4AC all over 2A. That gives us 8 plus or minus the square root of 8 squared minus 4 times -1 times 5 all over 2 times -1. All right, I come up with 64, I come up with 24, I have 8 plus or minus the square root of 84 all over -2. Now, square root of 84 is going to be about 9 point something. So second, square root 84, 9.2. So I have 8 plus or minus 9.2 all over -2. And I have 8 plus 9.2 all over -2. 8 minus 9.2 all over -2. And so that's going to be 17.2. 17.2 divided by 2. Answer is 8.6. And I get -1.2 divided by -2 is -0.6. Those are the two zeros. So automatically, I can begin graphing this. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And we know that we're going to cross at 8.6. And we know that we're going to cross at -0.6. Now, one thing we have is we have a negative for our A. With a negative for our A, that means we're going to be opening down, something like this. The question is, where's the vertex? Well, let's find it. Remember, vertex is opposite of B over 2A. So it's going to happen at I paused because I realized I made a mistake. The opposite of B over 2A is going to be 8 over -2, so we know the vertex is going to be -4, comma something. Well, if that's the case, I'd have a vertex here and two places I cross here, so I knew something had to be wrong. If I go back and I look, I have 8 plus 9.2 divided by -2 should be -8.6, ladies and gentlemen. So that's not where it crosses. 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's right in here. Those are our two places it crosses. 1, 2, 3, 4. The vertex is going to be somewhere on this one. And so we need to plug in -4 everywhere we see x. Negative of -4 squared minus 8 times -4 plus 5. That's going to be 16, but the negative out front means -16 plus 32 plus 5. So, -16 plus 32 plus 5. 21. And so in this case, we have a very tall graph. Its vertex is actually going to be way up here at -4, 21. Way up there. So our parabola looks very much like that. Now, the graph and the equations look all good, and we again come up with something that the vertex does make sense. It's a little high, but those are some pretty big numbers. So that's how we graph quadratics from a full quadratic equation.